Welcome back everyone. In this lesson we are going to begin to create our player controller. This is going to be a player who we can move left, right, up, down, and also have the ability to interact with things such as chests and enemies. So to begin, I'm going to go scene, new scene, and we want to have a root node of other node here, and I'm going to search up kinematic body 2D. And this kinematic body 2D node basically means that we have the ability to move this object around. This is really good if you're making a character, if you're making a platformer character, a top-down character, anything that you want to move based on inputs. Kinematic body 2Ds are really good as they also take collision into consideration. So I'm going to rename this by double-clicking, and I'm going to call it our player. I'm also going to save this, and I'm going to save it to our main folder right here as player.tscn. So save that. There we go. Now on our player here we need a few components. First of all, we need a sprite so we can actually see what our player looks like. Now later on we're going to remove this sprite and actually replace it with an animated sprite node so that we can have sprite animations. But right now while we're setting it up, we're just going to have in our sprite right here, so sprites, player, and I'm just going to drag in the player _s_0 node right here. There we go. We can select the player, set them to be in the center of the scene. There we go. And as this player, I'm going to rename the sprite to sprite. We also want to attach another node which is going to be of type collision shape 2D. So collision shape 2D, this is going to give us a collider so we can't just move through objects, we have to, we're going to bump into them. So we go shape here, and I'm going to set this shape to be a capsule. You can set it to be a rectangle if you want, but I just feel like capsules are really good if you're moving around corners, you don't get stuck. You can sort of slide around corners with capsules. So I'm going to resize the height here, resize the width, and just sort of get the rough dimensions of the player, something like that. So there we go. We've got our player right here. Now finally what we need is one more component on our player, and that is going to be a raycast 2D. So I'll show you what that is. We'll add child node, raycast 2D here, and what you'll see is a new node appear and this arrow. Now what a raycast is basically you give a raycast a position and a direction and maybe even a max distance, so it shoots a point from a position in a certain direction. In our case right now we're shooting it from the middle of our player downwards, and what a raycast does is it detects anything that it hits. So we're shooting a raycast downwards, so this point is going to keep moving down from our player, and if it hits another collider of another object, it's going to go, okay, I hit another collider, and it is going to return to us a bunch of information about what it hit. So it's going to return the object it hit, the distance away from it that it hit, and other specific information that we'll need. So we're going to be using this raycast in order to detect if we are looking at an enemy or if we're looking at a chest so we can interact with it. So right now we're facing downwards, so this raycast is going to be facing down, but if we move to the right, we're going to have our sprite flip to the right, and then we're going to have this raycast here also be pointing to the right. So in the inspector here, you'll see a few things. We have enabled, which we should actually enable right now, then you'll see it turns blue. We have exclude parent. Now, exclude parent should be on because if it's off, then it's always going to be detecting this player right here, because since the point is in the middle of the player, it's going to begin, alright, let's move downwards, and then it's going to go straight away, oh, we hit a collider because it's inside the player collider here. So make sure exclude parent is enabled so we're ignoring the player, and cast to is basically where we want this point to cast to, and anything in between this origin point and this end of the arrow, it has the ability to be detected by the raycast. And this is going to be changed, so if we're facing down, it's going to be facing, the arrow is going to be pointing this way. If we're moving to the right, then it's going to be something like 50, 0, like that. Okay, and this is all going to be changed in script. Exclude parent there. This is all going to be changed in script as we're moving around. But pretty much for our character right here, for our player, these are all the nodes we'll be needing. Again, later on we are going to replace this sprite node with an animated sprite node and create some sprite animations so that we actually have a walking animation and idle animations. But for now, we've got our scene here. Let's go back to the main scene, and I'm going to drag in our player.tscn. It should be down the file system if you save the scene. So I'm going to drag that in, just put it in the middle of the scene here, pretty much. We can then press play and see our player right here. So, of course, we can't move the player around just yet because we don't have the scripting functionality added in yet, but in the next lesson, we're going to begin working on that. So I'll see you all then. Welcome back, everyone. In this lesson, we're going to begin to script our player. In the previous lesson, we set up our player scene right here with our player and their corresponding nodes. Now we're going to actually script the ability for the player to move around, and then from there, we'll be moving on with the rest of the project. So we've got our player. Now let's select the main player node, which is the kinematic body 2D. And down in the script tab, I'm just going to create a new script called player.gd. Hit enter, and here we go. We've got our script right here. I'm going to delete this stuff here since we don't really need that. That's just more explaining how to do variables, how to do functions, stuff like that. But we do want to keep the extends kinematic body 2D line here because we do want to have many of the kinematic body 2D functionality that comes with the node. So we've got all this. Now what we need to do is first of all create our variables that we're going to be using. So first up, we're going to go var to define a variable. We're going to have cur HP, which is going to be our current HP. That's going to be of type integer, so it's going to be a whole number, and we'll just have that equal to 10. Along with this, we want to have a max HP, which is equal to 10 as well. We're going to have a move speed, which is going to be an int, and the reason why move speed is an integer is because this is determining how many pixels per second are we going to be moving at, and this is going to be 250 pixels per second. Then we want to have one for damage, so how much damage are we going to be dealing every time we attack an enemy? To make it easy for now, we're just going to have this equal to 1. We also then want to have a variable to keep track of our gold, so how much gold do we have? We're going to have 0 to start off with. Then we have our leveling. So with our leveling, we're going to have a current level and current XP. So we'll go var cur level of type int equals 0 by default, and cur XP, which is int, equals 0. Now, to determine how much XP we need to level up, we're going to have a variable called XP to next level. This is going to be of type integer, and this is going to be equal to 50 by default. So by default, we're going to need 50 XP to level up, but normally when you have a game with a leveling system, every time you level up, the XP to next level increases as well, because we don't want it to just stick on 50 XP to level up to every single level, as that'll probably take no time at all. You want it to go up by a certain rate every single time you level up. So to do that, we are going to create a variable here called XP to level increase rate. This is going to be a float, which is a decimal variable, and we're going to have this equal to 1.2. So every time we level up, this XP to next level is going to be multiplied by our XP to level increase rate. So let's just say we're on level 0 right now. We get 50 XP, we go to level 1, then this 50 here is going to be multiplied by 1.2, which is 60. Now we need sort of some variable for our interaction. How far away are we going to be able to interact with something? And this is going to be our variable called interact dist of type int, and this will be 70. So we're going to be able to interact with stuff 70 pixels away. And after this, we're just going to need a few more variables for our components and for our vectors. So first, we're going to have a variable called vel for velocity, and this is going to be of type vector2, and we'll just have this equal vector2 by default here. So this velocity here is going to contain our x and y velocity, how many pixels per second we're moving along the x-axis and along the y-axis. We're going to be storing that here so that we can know, okay, let's apply this to our player every frame. And then we're also going to have a variable for our facing direction. So facing dir of type vector2 again equals vector2. Now the facing direction is different from velocity because when we stop moving, velocity is going to equal to 0, yet the facing direction is going to stay whatever was the last direction we moved in. So if we move up, facing direction will be 0, 1. If we move down, it'll be 0, negative 1. If we move left, it'll be 1, 0. And if we move right, it will be negative 1, 0. So this is going to determine then what animation we're going to be playing based on where we're moving, which direction we're facing. And finally, for our variables for now, we're going to have a variable to keep track of our raycast. So we'll go raycast, and this is going to be needed to get when the game is started up, we need to get our node, so we're going to have this as an onReady variable, which basically means that whatever's after this equal sign is going to be called once this node here is initialized. So what we can do is we can go onReady var raycast equals get underscore node, and we can just then go raycast 2D. So it's going to search for this node once the game starts. Okay, so we've got our variables here. Now what we need to do is actually figure out what are we going to do for our key presses. How are we going to be able to detect our inputs, and what are those inputs in the first place? Well, Godot has a really good system in place called the input map, where we can create actions and assign those actions certain keys. So if we go up here to project settings, and then we go to the input map, you can see here that there are a bunch of actions already made for us, mainly to do with the UI. So what we're going to do is we're going to create 5 new actions. This is going to be move underscore up, hit enter, and at the bottom here you'll see that there is a new action called move up, and we're going to create the rest right now. So we've got move down, move left, move right, and interact. So there we go. We've got our 5 actions right here. So on move up, let's click on the plus icon on the right hand side. We then want to go key, and to move up, we're going to have this as the up arrow. So I'm just going to hit the up arrow right here, hit OK, and there you go. The move up action is assigned to the up arrow. For move down, we're going to have this to the down arrow. For move left, we're going to have this to the left arrow. For move right, we're going to have this to the right arrow. And for interact, we're going to have this on the space key. But if you do want to rebind these to whatever sort of key inputs you want, you can of course do that. You can even assign these to the mouse inputs, even joy buttons if you have a gamepad plugged in. Okay, so I'm going to hit close, and now what we can do is set up the ability to actually move around. So this here is going to be done inside of a function called func, and this is going to be called underscore physics underscore process, and you can see it right here. You can just hit enter. And this physics process function is built into Godot, and it gets called 60 times a second. Now, this function is similar to the process function without physics at the start, and the process function gets called every single frame. But the difference between that and the physics process function is that since this one gets called 60 times a second, no matter what the frame rate, it's very good for having physics in here. It's very good for calculating physics and applying those forces, because if you have an inconsistent core rate, it can have some inconsistencies with physics, as it's highly recommended to do all physics stuff inside of the physics function right here. And this delta parameter is basically the time duration between frames. So since we're running at 60 times a second, this is, I believe, 1 divided by 60, whatever that small value is. Okay, so we've got our function here. Now what we need to do is, first of all, set vel to equal vector2.0. So we're resetting our vector velocity here because we don't want this to carry over between frames. We don't want to be able to press the up arrow and release it and we're still moving upwards. We don't want that. We want the moment we release from the up arrow, our player stops moving. So we got that. Now we want to be able to work on our inputs, detecting when we press a certain key. So I'll just go hashtag inputs for a comment here so we know what's happening. And in here, we're just going to go if input.is underscore action underscore pressed. And this action here will be move up. So if we hit the move up button, then what we're going to do is we're going to set vel.y minus equals 1. And facing direction is going to be equal to vector2, 0, negative 1. There we go. We're setting our y velocity and we're setting our facing direction here. Now we can just go copy and paste this 4 times, or 3 times, so there's a total of 4. Replace this with move down, move left, and move right. So for move down, well, velocity.y is going to be plus equals 1, and the facing direction is going to be 0, 1. For move left, the velocity x is going to be minus equals 1, and the facing direction is going to be negative 1, 0. And for move right, we're going to have velocity.y plus equals 1 with a facing direction of 1 and 0. So we've got this set up, we've got our inputs detected, so when we press the up arrow, we're going to be setting our velocity and our facing direction. So from here, what we're going to be doing is making it so that these are then applied to our player. So we're then going to move in the direction of the velocity multiplied by our move speed. And we'll be doing that all in the next lesson, so I'll see you all then. Welcome back everyone. In this lesson, we're going to be continuing on with our player script right here, adding in the functionality for us to move our player around using the arrow keys. So in the previous lessons, we set up our variables right here. Some of them we're using right now, some of them we're going to be using a bit later, but we're setting them all up right here. Then inside of the physics process function, which gets called 60 times a second, we are first of all resetting our velocity vector. So this makes it so that if we press an arrow key, we don't keep moving in that direction even if we're not holding it. The moment we release that key, we'll stop moving. Then down here we're detecting our inputs because we created various different actions such as move up, move down, move left, move right, and these were assigned to certain arrow keys. So if we're moving up, we're setting our y velocity to -1, or we're subtracting 1 from the velocity.y, and we're setting our facing direction, so the direction that we're facing in. We're doing the same for move down, move left, and move right. Okay, so in order to move, all we need to do is call the move and slide function right here, and this is built into the kinematic body 2D node. And this basically takes into consideration collision, the direction the ground is facing. Now, since we're having a top-down game, we don't really need to worry about the ground, as that's sort of below us and kind of irrelevant to the game. So we just need to give it a velocity, and that's going to be vel multiplied by our move speed, so we can vary how fast we're moving right there. So this here is going to move the player. Now, if we press play, you'll see that we can move left, we can move right, we can move down, we can move up. But something you might also notice is that if we move diagonally, you can see we move faster. It seems like we move at a faster rate than if we're just moving along a single axis. So why is that happening? Well, if we quit playing the game here, that's something we can easily fix. With our velocity vector right here, it has an x and a y value. Now, if we're moving just up, the x value is 0 and the y value is -1. And the absolute value of that, if we get rid of the minus, so it's just a whole number, or a positive number, that is 0 plus 1. So the magnitude of this vector here is going to be 1, 0 plus 1. Yet if we're moving up and we're moving right, that's going to be 1 plus 1, so the magnitude of the velocity is 2. So you can see that we're moving faster if we're moving diagonally. Now to fix that, we can do something known as normalization. So down here, just under where we're getting our inputs, I'm going to go vel equals vel.normalized. And what this will do is this basically converts the magnitude of the velocity back down to 1. So instead of the x and the y being 1 and 1, it's going to be something like 0.5 and 0.5. So we're going to move slower on the x and y values, but the actual speed that the player's moving at is going to be the same as if we're moving along just one axis. So I'm going to add in a little comment here so it explains what we're doing. We are normalize the velocity to prevent faster diagonal movement. Let's press play and I'll show you how that works. So again, we can move left, we can move right, we can move up, we can move down, but if we move up and right, you'll see that we move slower than before. We don't move at the increased rate of speed because we're not adding in the x and the y velocity. We're moving along the exact same pixels per second thanks to normalizing the vector. And this is really good for pretty much every game that has movement. If you have players that can move diagonally, you always want to normalize the vector so that diagonal movement isn't faster. Okay, so we've got our movement here implemented. Now in the next lesson, we're going to be going over setting up some sprite animations because right now we have our movement, but it looks pretty bland. The player doesn't move, the player doesn't rotate to face the direction they're looking at. They just stay statically looking at the camera. So that's what we'll be working on in the next lesson.